So today we are going to talk about Hashtable / Hashmap. So what is a Hashtable or Hashmap? It's a data structure that maps keys to values, means like key value pair storage as one of the data structure. A hash table uses a hash function to compute an index into arrays or buckets or slugs. So during our lookup, the keys is hashed and the resulting hash indicates where the corresponding value is stored in a bucket or an array. So imagine like we have a list of integers and we want to put them into our hash tables. So first, we need to use a hash function to calculate the index to see where the value we're supposed to store it. But oftenly, there's a collection happens. It means like there's a same value that has a same, like they are not really same value. There's like, for example, different values has the same keys. So how we are going to deal with collections? So there's several methods. One is separate chaining hash, and another one is opening edges. Opening edges includes linear probing and conjective probing. And another method, we can use double hashings. So what is separate chaining hashings? It's pretty much as like we implement the arrays as a linked list called a chains. So separate chaining is one of the most popular and commonly used technique in order to handle collections. So for example, when we have repeated key for one of the values, so we can just add it at the end of the linked list, at the end of the linked list in that bucket. And so second one, linear province. So what is linear province? It's pretty much is the hash table is searched sequentially that start from the original location of hash. If the location that we get is already occupied, so it means we already have a key, we already have a value from the previous key. So then we need to check for the next location. So I have an example for this one. To make it simple, let's say our hash function is just simply key mod5, and the keys that we have are 50, 70, 76, 93. So our initialization of slots or buckets, we can call it like this, we can call it slots. We have 4 slots. Yes. And so our first key, we use 50 mod 5, we get 0. So it means we got to store 50 at the slot, at the index of 0 in the slot. So here we put 50. Then second one, we 70 mod 5, we get 0. But 0 is already occupied by 50. Then we just need to search the next empty space, which is 1. So we put 70 in 1. Then the next key, 70 mod 5, we get 1. But the slot 1 is already occupied by the previous key, 70. So we need to search the next empty slot, so which is 2. So we put 76 at slot 2. Then the next key, 93 mod 5, we get 3. But 3 is empty, so we put 93 at the slot 3. So this is linear problem, but like oftenly we can see like if we have this like we say clustering here, like there will be like a lot of like sequential consecutive space will be occupied. It means like when we try to search a next space for a key, it might take a lot of time to get an empty slot. This is one of the issue. So there's a more I would say more method that we can handle collection, like conjunctive problem, like the issue that conjunctive problem try to solve is like we were better than linear problem because conjunctive problem is like last consecutive space will be like occupied, and double hashing will solve the issue that linear problem and conjunctive problem have, which is clustering issue. For double hashing, it will not have any like clustering issues. So if there's some, if you want to know more about what is conjunctive problem and double hashing, you can let me know. I can have more details about this methods, how to handle collection in the future. Thank you so much for watching. If you like my video, please share and subscribe. Thanks so much.